Hello everyone. Today we are discussing Chapter 3, Lesson 4, Graphing Functions. So the objectives for today are to graph functions given a limited domain. And limited means it's not the whole domain, right? It's just a little portion of the domain. And then also to graph functions given a domain of all real numbers. Okay, so it looks like today we're going to be graphing functions, and it's really going to depend on this idea of domain. We're going to look at graphing functions when we have a limited domain, and graphing functions when it's all real numbers, which means the domain isn't really limited. Okay, so let's get started. Scientists can use a function to make conclusions about the rising sea level. Sea level is rising at an approximate rate of 2.5 millimeters per year. Do you guys know how big a millimeter is? A millimeter is really small. Really small. Let me see here. I'll show you. I actually have a ruler here. Okay, so you have inches, which are on this side. And then you have centimeters, which are on this side. And then a millimeter is just one of those little hash marks, right? So if I was to go to 0 to 1, it would just be from 0 to that first little, can you see it? That first little hash mark right there. So if it's saying 2.5 millimeters, it's like 2 of those and a half. So a really small distance. So the sea level is rising at an approximate rate of 2.5 millimeters per year. If this rate continues, the function y equals 2.5x can describe how many millimeters y sea level will rise in the next x years. One way to understand functions such as the one above is to graph them. You can graph a function by finding ordered pairs that satisfy the function. And so that's what we're going to do in our first example. So we have a function here, and what we're going to do is we're going to graph this function with this particular domain, -3, 0, 3, and 6. And this domain is giving us specific values, and this is what it's referred to as a limited domain. Because it's not all real numbers, right? It's only going to be these limited domain values, which are going to give us points. All right, so let's go ahead and look at this. So the first thing we're going to do is graph by using this table here. So we have this function, which is great, and we're going to plot in these domain values here. So we're just going to write these domain values in here, -3, 0, 3, and 6. But before we stick these into this equation or function, we're the same thing, we need to make sure that we solve this for y. We need to get y by itself. So I'm going to write this equation over here. And then we just need to use our algebra skills and solve for y. So I'm going to get the x on the other side. And so I have -x minus 6. I always like to write the variable first. That's going to set you up for something called slope-intercept form later instead of writing -6 minus 6. I mean, -6 minus x. I like to write -x minus 6. So you'll see when we get to chapter 4, but just trust me for right now. Write that variable first. Okay, then we're going to get y by itself. So we're going to divide everything by a -3. And so we end up with a negative and a negative is a positive. 3 divided by 3 is 1. We end up with y equals negative divided by a negative is a positive. So we basically have x over 3, and negative divided by a negative is a positive. 6 divided by 3 is 2. So this is our equation here when it is solved for y. And so that's what we're going to write in here. This This is how, because we need to find the ordered pair, right? So we know what x is. We got that from our domain. We need to figure out what y is, and this is the function that's, we're going to stick the x values in to figure out what y is. So I'm just writing that here. Okay. Now we're just going to stick each one of these values in. So I'm going to stick, we're going to go y equals -3 in for x over 3 plus 2. Okay, just sticking that value in for x. And that equals -3 divided by 3 is -1 plus 2. And that ends up being, let me see if I can scooch it in there, 1, right? So that means we end up with the point -3 is our x and +1 is our y. And so we can plot that point. -3, 1, 2, 3, +1, that point is right there. So we just graph the point. Okay, let's do the next one. So we have y equals 0 over 3 plus 2. Well, 0 over 3 is just 0 plus 2 equals 2. So our point is x is 0 and the y is 2. So now we have 0, 2. That's another point on the graph. And then we're going to do this again for 3. So 3 over 3 plus 2. 3 divided by 3 is 1 plus 2. 1 plus 2 is 3. So we have the lovely point of x is 3 and y is 3. So 3, 3. And lastly, we have 6 right here. So that's going to be 6 over 3 plus 2. 6 divided by 3 is 2, plus 2 is 4, which we end up with the point 6, 4, and that point is there. So if you look at this, you can see that all of those points line up in a beautiful line, right? I could draw a line. However, I'm not going to draw a line, and the reason is because it's giving me this limited domain. So when they give you a limited domain like this, what you're going to be dealing with is a discrete graph. Okay? So, it's not a continuous graph, it's a discrete graph. So whenever that domain is limited and it says graph the function for the given domain, it is telling you what that domain has to be, their specific values, which means the domain is limited, and because it's limited, you're only going to end up with ordered pairs, which are points, which are going to make this a discrete graph. All right, so really these problems in this chapter, this lesson that we're going to be dealing with is domain. And when you have a domain that's giving you a discrete graph versus when you're giving a domain that is giving you a continuous graph. Now, some people might think, oh, these lines are all aligned, I'm going to connect them, right? But once you connect those lines, then that means you have domain values for -2, -1, -0.5, 1, 2, all of those values in between these specific domain points, and that just isn't in the domain. The only values for the domain is when x is -3, when x is 0, when x is +3, and when x is 6. Okay, so that means we end up with this lovely discrete graph here. All right, let's go ahead and try this again. So for 1b, we are given a different function here. And it says graph the function for the given domain values. So here we have specific domain values once again. And so -2, -1, 0, 1, and 2. Okay. What's nice about this, this is in function notation, so we know this is y equals x squared minus 3. So we already know this is isolated for y, because f of x is the same thing as y. And since we have these specific domain values, you know we're going to be dealing with points, and so we're going to end up graphing distinct points, which means this is going to be a discrete graph, okay? So let's go ahead and get started. Just because of room, I'm not going to write the f of x here. I'm just going to plug this number in for x. So it's going to be negative 2 squared minus 3. Negative 2 squared would be negative 2 times negative 2, which would give us a positive, 2 times 2 is 4. 4 minus 3 is 1, so we end up with negative 2, 1. All right, and so that's this point, negative 2, 1. It's a lovely point. All right, then we're going to do the next one, negative 1 squared minus 3. We just stick the x in here. That is going to, negative 1 squared is negative 1 times negative 1, which is a positive 1, minus 3, which is negative 2. We end up with this, negative 1, negative 2 right here. And then let's find the domain value of 0. So that's going to be 0 squared minus 3, which 0 squared is just 0, so it's negative 3. So 0, negative 3, x is 0 here, negative 3 is down here. And then when the domain value or the x value is 1, so we're going to go 1 squared minus 3. 1 squared is 1. That means 1 times 1 minus 3 is negative 2. So, and then our last one is when x is 2, so 2 squared minus 3. 2 squared is 2 times 2, which is 4 minus 3. 4 minus 3 equals 1, which means I'm left with the point 2, 1. 2, 1 right here. Oh, did I not graph this one? Oh, I'm sorry. Oops. So that would be, this one was 1, negative 2 here. And then finally, make sure your ordered pairs have parentheses. Ordered pairs have to have parentheses. So make sure your ordered pairs have parentheses. Right there. 2, 1. And so there's our lovely discrete graph. It's a discrete graph because our domain is limited. Okay, so we wouldn't go back and draw a line through that because that wouldn't be the story of what this is saying. This graph is only asking us to graph for when x is negative 2, when x is negative 1, when it's 0, when x is 1, and when x is 2. So we're doing that. It's ordered pairs. It's a lovely discrete graph. All right, make sure that when you're doing these problems that you show your work. When they ask you to do this, you have to make a table. You have to show all your work like this in the table, and then you have to make a graph. So make sure you have graph paper at home too. That makes it easier. All right, now it is your turn to check it out. I want you to try this problem here. Okay, I'm trying to get it lined up with I'll just check it out 1A. And here's my friend, the pause dragon. Remind you to pause your device. When you get done, press play and we'll talk about it together. All right, see you in a bit. All right, let's see how you did. So we have to graph the function here for the given domain. The first thing that I'm seeing is we need to solve this. Negative 2x plus y equals 3. We need to solve it for y. So we need to get y by itself. So we need to do a little algebra first. So I'm going to add 2x to both sides. That leaves with y equals, remember we're going to put that x first, 2x plus 3. Now that is my y value. Y equals 2x plus 3. All right, and then for these domain values, so negative 5, negative 3, 1, and 4, those specific. So I'm going to have ordered pairs, which is going to give me a discrete graph. And then I'm just going to go ahead and plug this in. So we have y equals 2 times negative 5 plus 3, which is equal 2 times negative 5 is negative 10 plus 3 equals negative 7. So we have the point negative 5, negative 7. Negative 5, negative 7 would be right here. Right there. So negative 5, negative 7. Perfect. All right, let's do the next one. Y equals 2. We're substituting this x value in here. Negative 3 plus 3. 2 times negative 3 is negative 6 plus 3 equals -3. So you should have the ordered pair -3, -3. -3 is right about there. All right. And then we have when this x value of 1. 2 times 1 is 2, which gives us the 0.15. So 1, 5 is right here. And lastly, when x is 4, so we substitute 4 in for x. 2 times 4 is 8. We end up with the 0.411. Ooh, this one might be a challenge to graph. So 411, I'm going to say 11 is right there. So it's going to be right there. And this definitely looks like a line, but because it's asking for specific domain values, we do not connect the dots. We only just leave these ordered pairs because that's what it's asking us to graph. It's asking us to graph for the specific domain value of -5, -3, 1, and 4. So that is all we graph. We are done. If you have your problem done and it looks exactly like this, great work. Let's go ahead and practice this again with check it out example 1b. So you have this graph here, and here's my friend the pause dragon. Remind you to pause your device. Go ahead and work this problem out. When you get done, press play and we'll talk about it together. All right, see you in a bit. All right, we're back. Let's see how you did. So we have these. This is nice. It's already solved for f of x. So f of x equals x squared plus 2. We're going to solve it for these specific domain values. So we're just going to start substituting it in. I'm not going to write the f of x because I only have a limited amount of space. So we're going to start by substituting this x value in here. So -3 squared plus 2. -3 squared is -3 times -3, which would be a +9. Plus 2 gives us 11. So we end up with -311. Let's go with -1 as the x value now, and you just kind of do the same thing. So we end up with -13, and then 0 is our x value. 0 squared is 0, plus 2 is just 2. So that's a lovely point there. And then we're on to this x value. 1 times 1, or 1 squared is 1 times 1, which is 1. Plus 2, so it's 3. So we have this ordered pair. And then finally, we have 3 squared plus 2. 3 squared is 3 times 3, which is 9, plus 2, which gives us 11. All right, now we're just going to graph these ordered pairs. So we have -311, which is right here, -1, 3, which is here, 0, 2, which is here, 1, 3, which is here, and 3, 11, which is right there. And we have another lovely discrete graph. So if you have this and it looks exactly like mine, awesome job. If not, just go ahead and erase your work and make sure that your work looks exactly like mine. All right, well, that's it for this example. I'll see you in a little bit for example 2.